So again, we're going to pick up where we left off with solving trigonometric equations. We're going to solve the equation 3 sine x plus 1 equals 0, and we're going to solve that in 4 different ways outlined here. Okay? So regardless of how we want to report our answer, the first step is to try to get the x by itself. Everybody's okay with that plan? So I'm going to start by subtracting 1 from both sides. And then dividing the 3 from both sides. And then who remembers what the operation was that cancels off the sine part of sine x? Sine inverse. So we do sine inverse of both sides. And then that's going to give us sine inverse of 1 over 3. Now, if I recognize that quantity 1 over 3 as a unit circle value, I could go to my unit circle to find the angle measure for this. But is 1/3 one of the values on my unit circle? No, it is not. If you said yes, you should spend another minute looking at that unit circle and just 1/2 is. You're thinking of the radian, like you have 2 pi over 3 radians, but when we say unit circle values, we mean points on the unit circle, rather than unit circle angles, which would be like 2 pi over 3. So how would I find what sine inverse of 1/3 is then? I'm going to use my graphing calculator. So the first question becomes, which mode should I be in, radians or degrees? Well, let's try to work on part A. So what kind of measure is part A in? Degrees. So when I look at my calculator, I will use degrees. So I'll start by looking at my mode, and I have mine in degree mode already. If yours, when you check your calculator, is not in degree mode right now and you're following along, you should put it in degree mode. Should it always be in degree mode? No. So for example, if you look at part B, what mode should part B be? Radian. Everybody's okay with that? Okay, so depending on how we ask the answers are going to depend on what mode your calculator should be in. So make sure you're reading those directions before you start these solving problems and that your calculator's in the correct mode to do this. All right, since we're in degree mode, I'm going to do sine inverse of 1/3. Oh, sorry, the negative 1/3, excuse me. Did I forget to write it? Yeah, my apologies. Yeah, negative 1/3. Okay. Everybody good with what we typed in the calculator? Okay, let's spit it out. So negative 19.47 degrees. Now, look at my answer again on where we're supposed to report that. Is that one of the values that I'm allowed to report? No. So what I'm going to do is I'm going to draw a picture of kind of what's going on to help me understand what answer I've just been given. Because I got an answer, but it's not the one that I was looking for. So negative 19.47 degrees is here. Everybody agree with that? That's the same thing as this angle that will have a positive angle measure and will be less than 360 because it's less than a full circle, correct? So to find that, I can just add 360 to negative 19.47. So 340.53. That's one answer. Is everybody happy with how I got to that one? Okay. Now, remember, all silly turtles crawl. There's another place where sine is negative. What quadrant is that? Quadrant 3. So that angle where, or that place where sine is also negative 1/3 is here. If I was on C, what? Part C. Yes, and in fact, we're going to show how to do parts B, C, and D are just, I'm going to use all the information that I have right now and just modify the answers that I'm getting to get those other pieces. So yes, the information that I have now is going to allow me to do parts B, C, and D, all without doing much more than this. But I wanted to start on this one, which is kind of the most basic case. And we can, if we get these answers, we can use those answers to get all the rest of them, depending on how we're at, what we're asked for. Okay, so I wanted to start there. Everybody's okay with that plan? Okay, so we also have this angle here in red. That's going to be our other solution, or an other solution. Are there any other places between 0 and 360 where sine is negative? No, right? Just those two places. Everybody agree with that? Okay, so the key observation is, how much is that little spot there that I've drawn in squiggles? Well, it's positive 1947. Because again, we're going, you know, like that much of it, right? So we're still going in the positive direction. Good. So the whole thing is 180 plus 1947, because we did half a circle, oops, from here to here. And then we did 1947 more. Is it always going to be 180 plus that? No. I want to reiterate that. Is it always going to be 180 plus your angle measure? No. What are you going to have to do? Draw a picture. It's always going to be like one of the quadrantals plus or minus that angle measure, but whether it's 90 plus or minus, or if it's 180 plus or minus, or 270 plus or minus, or 360 plus or minus, that'll change depending on the problem and the trig function you're working with and whether the sign is positive or negative and all those things. But it's easy to figure that out if you draw the picture and look at the picture. Is everybody okay with that? So I want to be clear that there's not like a prescriptive, it's always going to be this way. You have to draw that picture and you have to look at what's going on in the picture. So doing this, we get our other answer. So 19.47 plus 180 is 199.47. This is our answer for part A. Everybody happy with that? In part B, we ask you to solve the same equation, but we want our answers from 0 to 2 pi. So what do we need to do to that? I just need to convert these two from degrees to radians. Does anybody remember what the conversion is from degrees to radians? So our two conversions are these. The one that I'm going to use, though, is this first one, where I start in degrees and I end with radians. Everybody happy with that? So I will start with 340.53, and I'll multiply that by pi over 180, and that will give me an answer. And then I will do 199.47 and multiply it by pi over 180. And that will give me my second answer. Is everybody okay with that plan? Again, trying to do this in a way that shows you that it's really kind of the same basic process. Notice what we would have done if we asked to do part B alone. I would have done exactly what we did for part A, and then I'll just convert my answers at the end into from degrees to radians. So if I had not asked you to do part A and only asked you to do part B, I would do it the exact same way that we're doing now, right? I would just go ahead and pretend the problem had a part A to it. I would do that part A, and then just convert my answer at the end. So that's my solution then to B. Everybody agree with that? I'm going to take your silence as we're okay. So what we hopefully noticed in part A is that I had two solutions for every 360 degrees. Everybody's kind of going to agree with that? That if I tack on another 360 degrees, in either direction I'm going to tack on two more solutions for every 360 degrees I add on to this. In part C, I think we said it was negative 720 to 360. Is that correct? Is that what we wrote down? Okay, good. So I'm going to just kind of draw a picture that we had from part A. Actually, let's do some colors here. That'll make life a little bit easier. Yes. Yes. Is everybody okay so far? So I haven't done much, right? I did all the steps from part A. So now I need to get the answers for this part. Everybody agree with that? Because we've already written down the answers for that part. You guys buy that? Okay. So this value is my first solution, correct? How do I get that? I subtract 360 from this. Well, what kind of angle is that red angle now? It's coterminal, correct? Coterminal to the other one, so it's going to be either 360 more or 360 less than that angle. Because I'm going clockwise, I know we're going in the negative direction, so I should be subtracting subtracting the 360. Is that okay, Julia? Oh, we did. These are all answers. So I've already started listing them. I took my 2 answers. I started with the biggest one, and I'm going to go to the smallest one. Is that okay? Okay. So yes, we absolutely took those answers. We used those answers. We're going to keep those answers. They're good answers. They're answers that we need to list. There's just some more stuff that we haven't listed yet. Then I also need this angle. So what am I going to do to 199.47 to get that angle? Subtract 360. So that should be -1, ooh boy, 60.53. Are we okay there? But I know since we're going all the way out to -720, I can go around twice on this. So I can do that. So how do I get that answer? I just subtract 360 again. Okay to there. And then one more, I can do that one to there. How do I get that? I'll just go to that other angle and subtract 360 again. And if I try to do another one, I would go around once, twice. That's already 720, and to go a little bit more is going to get me something too small, right? So if I subtract 360 again, I would get 739.47. And this is too small. It's negative 739.47. Is everybody happy on that? So again, it's exactly the same as part A, just we might have to do some adding and subtracting of 360 to our answers a couple of times, right? Everybody's okay with that? And you don't even have to think about it more than that. You can just take your answers and just add or subtract 360 until you stop getting things that are in the interval values you're looking for. So it doesn't have to be any more complicated than that. For this part, for the solving part, it does get more complicated, unfortunately. But I'm trying to start with just like getting you comfortable with how do we report our answers, right? Because the solving part in the beginning can get more complicated, Sophia. But I wanted to start just with something that's like the solving part is easy, and just worry about how to report these answers. And worry about that for right now, and then we'll make the solving part a little bit more complicated once we feel good about reporting and finding the answers that we're looking for, and the proper number of answers and all the answers. Is that okay with you, Sophia? Okay, so I just want to, again, be clear. This will get can get more complicated, and I don't want to do like the most complicated thing to start with. I want to try to start out with something where one part of it is tricky, and see all the little variations in that one part. And once we feel okay about that, then move out and add like another layer onto it and work in there inside of that layer and then move out again. If that makes any kind of sense? So it's not so overwhelming all at once. Because this is tricky, right? Like it's not trivial, it's not easy, it's new, it doesn't feel comfortable. Okay, and part D we asked for all the solutions in degrees and then all the solutions in radians. So what I'm going to do is I'm going to go back to my answers from part A. So those are my two possible answers, right? And then I know every 360 degrees, I get another solution. So to get all the solutions in degrees, all I do is take my answers to K and add on, or my answers to part A, and then put that plus 360K, K an integer at the end. Didn't require any more thought than that. All that's saying is that if I start at 360 or 340.53 and keep adding multiples or subtracting multiples of 360, I get another answer. And that's how you find all of them. Is everybody okay with that idea? So again, doesn't require any thought. Just know that when we're asking for all solutions, you're going to have something like this kind of tacked onto the end of it. If we're in radians, instead of starting with my answer for part A, I'm going to start with my answer from part B. Why part B? Because they're in radians already. So 594 and then 348. And when we're talking about radians, what is 360 the same as? 2 pi, right? So instead of putting plus 360k, I'm going to put plus 2 pi k. Will I do that every single time? Yes. So again, all we did was took our answer in radians and we wrote plus 2 pi k after it. Now, you might be asking, well, Mr. Kulik, we had a whole bunch of answers that we said were equivalent to 340, right? We had 340.53, and we had negative 19.47, and we had negative 379.47, and negative 739.47, and we had a bunch of, like a bunch of other answers, right? What happens if it would still be okay if I wrote negative 19.47 here instead of 360.53? Yeah, that's fine. Now, will that be the answer in the back of the book? Decidedly not. The standard when we write these infinite answers is always to give our angle between 0 and 360. But it's not incorrect to not do that, right? It's just like if you write 4 over 2, it's still the same thing as 1/2. And I won't be so picky that you have to report those between 0 and 360. If you have an equivalent answer, that's okay. But the standard, the typical, is to give those answers between 0 and 360. Is everybody okay with that idea? All right, let's do another one. Everybody good for that? All right. Whoa. I moved the cord. There we go. So another example. Actually, let's do that and make this a little bit sneakier. So so let's say we're going to solve for a from 0 to 360, and then all solutions in radians. So we're going to answer this two ways. We're going to just find the answers between 0 and 360, and then write all of the solutions, but answer that in radians. Okay, the first step is to get the x by itself. So we would want to subtract 1 from both sides. I heard some mumblings of that. Now what? Divide by 4. Okay. And now what does tan squared x really mean? We said it was really meant this, right? But we chose not to write it that way because it saved us from having to write all those parentheses all over the place. So how do I get rid of that squared there on the outside? I have to square root both sides. Oh no. Hold on a second, guys. I did something very bad. Okay. Now everything is okay. We're about ready to square root a negative, which, bum, 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 bad things happen. We're not in like an honors class here where we're going to deal with imaginary values for trigonometry. Like, no way, Jose. When I square root both sides, though, of an equation, something very important happens that we have to remember that probably 9 out of 10 of us would forget to do. Plus or minus. Right? Whenever you square root both sides of an equation, you get a plus or minus. What are you probably going to forget to do when you square root both sides of an equation? Write down the plus or minus. Why am I making a big deal out of this? Hopefully some of you will remember to write down a plus or minus when you square root both sides of an equation. Got to remember that. It's very important. It happens a lot. It's easy to forget it. That's why I'm reminding you like 16 times right in a row right now. And what's the square root of 1/4? It's the square root of 1, which is 1, over the square root of 4, which is 2. So 1/2, or 0.5, I heard somebody say. Everybody's okay here. Now, because of this plus or minus now, we have to, here comes the tricky part. I'm going to treat this as two separate problems. I'm going to treat it as tan x equals 1/2, and then also tan x equals -1/2. Everybody okay with that? Because I don't know how to do the tan inverse of a plus or minus, but I can do tan inverse of the positive, and I can also do tan inverse of the negative. Okte-dote. So I get x equals tan inverse of 1/2. And then when I tan inverse both sides of the other one, I get x equals tan inverse of -1/2. Now, if we look at our unit circle, is 1/2 a value for tangent? Nope. So what should we do? Calculator. Before we do that, what mode should I be in? Degree. Okay. Which is where I left my calculator, so I don't have to do anything there. 1/2. So 26.57. And then if I do negative I get negative 26.57. So here is one of my answers. Is this one okay? Negative 26.57. Is that one of the ones I'm looking for? It's not. What's wrong with it? It's not between 0 and 360, right? So what can I do to that to get it in a value between 0 and 360? Just add 360. Yeah. So that's 333.43. Now remember that tangent is positive in two locations, right? What's the other quadrant that tangent is positive in? All silly turtles crawl, so it's quadrant 3. So how far is this part here? Well, that's 26.57. And how far is this part to there? 180. So I have another answer at 206.57. I'm sorry, what did you ask? There's no real reason. And if I look at the negative answer, or this one here, tangent, how many places is tangent, or where else is tangent negative other than the fourth quadrant there? Also negative in the second quadrant, right? So how far is this spot here? .57. And how far is this spot here? 180. So the angle I'm looking for is 180 minus 26.57. So when I do that, I get 153.43. Is everybody okay with how I pulled out those 4 solutions? All right, so that's our answer to part A. To do part B, what do we need to do? Well, first thing, I need to convert these answers into radians. So if I do 26.57 times pi divided by 180, I get 0.46. And then I'll say plus 2 pi k an integer, right? And then I'll look at this one. So that was 206.57 times pi over 180. So that's 3.61 plus 2 pi k, kn element of the integers. And then we'll go to our next answer. So 0.43. Go away. So that's 268. And then our last one, 343.43. So 599. And this answer is fine for me. I would give you full credit for this on the test. But if you looked at this problem in the back of the book, this is not going to be how they write their answer. What do you notice about the difference between the values here and here? Oops. Draw that the other direction. You notice that they're 180 apart, hopefully. You guys okay with that? So if I look at this first couple, I have an answer here and then an answer here. So if I go 180 from that answer to that answer, I do another 180 and I'm back again. So what the textbook will do in the back is they'll just take one of the two, and instead of adding 2 pi k, or 360, they'll combine both of those and just add 1 pi k, or 180. Now, do I expect you to catch that on the quiz or whatever, the test? No. It's okay to just write it this way. That's okay. But I would say I'd probably give you extra credit if you notice that you could combine those infinitely many things into a more condensed answer, the way the back of the book would. In the green? So all I did was I took like this answer and converted it to radians by multiplying by pi over 180. So that's where all those decimals came from. It's just converting my answers in the part A into radians and then tacking on the plus 2 pi k at the end. Since we wanted all the solutions in radians for part B. Okay with that, Julia? Okay. So this is probably good to hear. Let me find something for you guys to practice with tonight. Oh dear, some of these are going to be harder than I want it to be. What are we ready to do right now? Was that a sound effect from somebody's room? That was weird. Let's do 63 to 68 right now. Those are all relatively easy. They say all solutions for those, but they don't tell you whether they want them in degrees or radian. So let's do the odds as degrees and the evens as radians. No, it just, the problem only asks you for all solutions. I'm just saying when you write all solutions for the odd problems, do it as degrees. So like plus 360k. And for the evens, write them as radians plus 2 pi k. So that's all I'm asking, is that you do a little bit of both. Or use degrees and use radians. Does that make sense what I'm asking for? I don't know that we did specifically. Like here, this is all solutions in radians. Right, yeah, it would be similar to this one here, where you just would solve it all just between 0 and 360 in degrees. And then if it's the odd, you just tack 2 pi or 360k at the end of it. And if it's even, you convert them into radians and then tack the 2 pi k on.